Hello, everybody. Can everyone hear me? I would like to welcome you very, very warmly to the launch of the UKRI Interdisciplinary Centre for Circular Metals. I am Mark Miodowink. I'm part of the research team, which is being led by Brunel University. And it's very exciting for me to be able to kind of hand over to you to formally welcome you all and to start to set the scene for where this centre is coming from and where we're going. I'm going to invite onto the stage Professor Julia Buckingham. She is Vice Chancellor for Brunel University, and she is President of the Universities UK. Julia, can I invite you onto stage to say some words of welcome to all our attendees around the world?
Well, thank you very much indeed, Mark, and it's a very great pleasure to be here and to welcome all of you to this event. If only virtually, I'd love to be coming on to a real stage. We really would have loved to have hosted you all on our campus. It looks so fantastic at this time of the year. I was there at the end of last week and it looks so beautiful, but hopefully in the not too distant future, that may be once again possible. But it is a huge pleasure for me and for my colleagues to be launching our new Interdisciplinary Centre for Circular Metals, funded, of course, by UKRI. And this centre is a wonderful collaboration led by the Brunel Centre for Advanced Solidification Technology, better known to most of us as BCAST here at Brunel University, London, with our university partners, the Bartlett Institute for Sustainable Resources at UCL, and the Warwick Manufacturing Group at the University of Warwick. The centre also has a huge range of industrial partners, some 30 to 40, and its objectives is to make the UK the first country to circulate metals fully by 2050. Now, I'd like to start by congratulating all of those who worked so very hard to develop this proposal to UKRI, and to thank our many partners across academia, industry, government, and of course UKRI that supported us in establishing this centre. Now, unfortunately, there are far too many partners for me to name individually, but my thanks very much goes to all of you, and I think it's a promising sign of the success and impact that this centre will have on the future, that we've got so many people who've committed to work together on it. Now I'd like to take you to imagining a rather grim scenario where global resource extraction has almost doubled to 177 gigatons per year. The global population is at 10.2 billion, and greenhouse gas emissions are at 60 gigatons per year. Yes, that's absolutely mind-blowing. And unfortunately, that's a scenario that's been forecast for us by the International Resource Panel in just 29 years from now, 2050. That's not very far away. And that is unless, of course, we do something. And of course, this is leading head on to a collision between our shrinking global ecosystem and our ever expanding human economy. So it's absolutely critical that we do act now. And it will be through circular economy approaches, such as those that will be investigated in this centre, that we will provide effective mechanisms to decouple economic growth and rising living standards from resource consumption and environmental damage. Universities are going to play a key role through collaboration with industry and government in road mapping the circular economy of the future. We see the Circular Metals Centre as forming an integral part of the UK national R&D infrastructure and becoming a key driver for the UK's green industrial revolution, revitalising UK metals supply chain in support of the government strategy for net zero by 2050. Circular economy is an increasingly important emergent scientific field. The Circular Metals Centre will support the UK government's goal of green recovery and transition towards a circular economy. At Brunel, we've identified sustainability as one of our 5 strategic challenge areas, circular economy being central to this challenge. And it's fantastic to see that this interdisciplinary centre will be a key part of us delivering impactful research that focuses on providing knowledge, insight, and innovative technological breakthroughs to enable efficient uses of resources, transformative economies and behaviours, and the mitigation of the impacts of climate change. During my tenure of my present role as President of Universities UK, I've championed the important role that universities must play to help to secure a sustainable future for our planet. Climate change is one of our key strands in the Vision for Higher Education that we published at the end of last year. So it brings me real pleasure that this centre will further the commitment to maximising the social and economic values of universities for the benefit of students, communities, businesses, and civil society through research, teaching, knowledge transfer, the pursuit of truth, and the free exchange of ideas, furthering the role of UK universities as global leaders in education, research, and innovation. So once again, I'm pleased to announce the Interdisciplinary Centre for Circular Metals is now formally opened. I'd love to have a ribbon to cut, but afraid we'll have to have a virtual one. But I hope the rest of you enjoy this launch event, as we've got some really great speakers lined up from across industry, government, and academia. And we're very much looking forward to interacting with you and making a real impact into a circular future for the metals industry. So thank you so much for your time. I'm going to hand back now to Mark. But just before I do, I'd like to say a special welcome to our next speaker, who I believe is Baroness Brown, former Dame Julia King. Julia and I are former colleagues, and of course she is an honorary graduate of this university. So welcome, Julia, but back to Mark first.
Thank you, Julia. That was Professor Julia Buckingham, Vice-Chancellor of Brunel University and President of the Universities UK, giving us the introductory welcome speech for this research project and this research centre, which we hope will have a huge impact in getting metals circular, in not just in the UK, but globally. And I noticed that we have a lot of participants worldwide, and welcome to you all, wherever you are in the world. Now, we've got a packed schedule today. I'd like to now hand over to Baroness Brown of Cambridge, Professor Dame Julia King. She is chair of the Adaptation Committee, the Climate Change Committee, and chair of the Climate Trust. So she is extremely well placed to set the scene, really, for why this centre is going to play such a vital role.
Congratulations on the opening of the Circular Metals Centre. This is both a critical and a timely initiative. It's critical, one, because we need to reduce greenhouse gas emissions globally to net zero between 2050 and 2070 if we are to keep global temperature rise to below 2 degrees and ideally to closer to 1.5 degrees by the end of the century. And we should remember, and it's rather alarming, that we're already at 1.2 degrees above pre-industrial levels on average today. To meet net zero, we're going to need lots of new infrastructure like zero carbon renewable energy through offshore wind farms and electric vehicles. Infrastructure like this needs lots more materials such as steel, aluminium, and other metals and alloys. But we know that metal production, mining and refining is environmentally damaging, energy intensive, and a major greenhouse gas emitter. Currently, steel production accounts for something like 10 to 15% of global carbon dioxide. So we need more of these materials with less damage. And that brings me on to the second reason why this is critical, because we need more of these materials. We have just under 1 billion cars in the world today. By 2050, we'll have seen population growth, and the developing world will have seen its GDP grow and will be aspiring for the things that we take for granted today. We could have 2 to 3 billion cars, and that's just one example. But of course, we can't just go on extracting more resources from our planet and creating more waste. So a big part of the answer to both of these issues is the circular economy, the reuse, repurpose, remake, and recycle. And metals are great candidates for this, but it's pretty shocking that we currently only recycle about 50% of steel, and then we take it back through energy-intensive refining processes. How do we move on to not only recycling 100%, but actually to reusing and repurposing, not just recycling? And the low carbon economy itself brings new challenges. Some of the critical ingredients are going to be those batteries, electric motors, fuel cells, electrolyzers. All of these rely on some of the less common metals, such as cobalt, lithium, rare earths, platinum, iridium. It's going to be absolutely essential that we use these again and again if we're going to be able to deliver the electrification that enables and underpins achieving net zero globally. I haven't mentioned timely yet. Timely, of course, because of the urgency of delivering net zero, but also timely because there are some new technologies around that can really make a difference if we use them effectively. Digitalization and digital twins will enable us to know exactly what materials go into everything we make. Low-cost plastic traceability and recoverability can be supported by blockchain. Big data will enable all of these technologies and lead to better materials design and design for reuse, remanufacture, and recovery. So I'm looking forward to my next electric car having a sticker on it that says, the lithium in this battery is appearing for the 15th time, like some kind of lucky lottery ball. And you, I hope, are going to be part of making this a reality. This is a hugely important challenge. So the very best of luck with it, and many congratulations again on the launch of the Circular Metals Centre.
Thank you very much, Baroness Brown of Cambridge. So for those of you joining us late, that was just setting the scene by Professor Dame Julia King, who is also chair of the Adaptation Committee and Climate Change Committees of our UK Parliament, and she's chair of the Carbon Trust. So we understand why this new centre is needed. We understand why metals are absolutely vital if we're going to reduce climate change and get to a circular economy. But how are we going to do it? And who is funding this research? Now I'm going to hand over to Nick Cooper, who's interim head of the circular economy at the EPSRC and UKRI, which are, for those of you joining us from around the world, they are the preeminent research councils in the UK funding this research. Nick, can I hand over to you?
Thanks very much, Mark. I'll just share a few slides, which hopefully you can now see okay. So, good morning, everybody, and it's lovely to be here today at the Circular Metals launch. I've been involved in this programme since 2019, when we wrote an initial business case to get this funding, and it's great to see this all come to fruition today. So I'm just going to talk briefly, as Mark said, about some of the policy context and the funding that has brought this centre into being. So for those not familiar, UK Research and Innovation is the government's research and innovation agency, formed of a number of individual councils covering separate disciplines, as well as Innovate UK, the innovation agency providing business funding additionally. And our funding comes from central government, but we are a separate organisation. And our role is to provide that infrastructure and the funding that's required to deliver against government commitments, as well as ensuring that discovery research is always coming through the pipeline. And it's a very important context that all of this work sits within for the UK government at the moment. The government is trying to make a case for a green industrial revolution, which is trying to build back better following the COVID-19 pandemic. And what is important here is aiming to move towards net zero by 2050, as has already been discussed. And importantly, the government has recently announced that we're going to be setting a target of 78% reduction in our carbon emissions by 2035. And getting there involves a lot of research, a lot of new technology, a lot of new innovation. And that's where programs like this are so crucial to delivering against these key policy commitments. And you'll see on the slide, the government set out a 10-point plan for this revolution. Some points to particularly point out are the acceleration of the shift to zero emissions vehicles, which require a lot of the metals that this centre will be exploring, trying to protect our natural environment as well, and also advancing offshore wind. And as Baroness Brown has said, this is going to be critical getting this research and getting these metals in place. Another thing is the government's industrial decarbonisation strategy, which specifically discusses the importance of resource efficiency in sectors such as the metals industry, and trying to increase the amount of reuse, repair and remanufacturing, as well as looking at recycling and recovery as well. And as I've said, research and development is critical to achieving this, and the government's UK Research and Development Roadmap sets out a plan to increase the amount of spending on R&D to 2.4% of GDP by 2027. And that's going to involve public funding provided by the likes of UKRI, but also increased investment from the private sector as well. And this is where joining up discovery research going on within universities and more applied research and innovation going on in business is critical. And that's where programs like this hopefully will catalyse a lot of this joining these things up. And this year is particularly important. The UK will be hosting the COP26 Climate Change Summit in November. And this is a great opportunity to showcase the research that's being done within the UK and to build new partnerships and global commitments in areas such as circular economy. The government will also be publishing further strategies, including its net zero strategy this year. And UKRI has been working to ensure that we actively engage with this to make sure that research and development and the importance of that is features within these strategies. And for UKRI, we are continuing to make the case for additional funding for research and innovation, and having early outcomes and impacts from centres such as this are really crucial for showing that the funding that we provide can have impact and can deliver against government commitments as well as supporting industry. And for UKRI, we have our own environmental sustainability strategy that we recently launched, and we want to make sure that research we're funding is delivering against that. And some of our commitments are on the right-hand side of this slide. But we want to ensure that we are funding research that's supporting environmental sustainability, as well as trying to be sustainable as an organisation ourselves. And circular economy is critical to that, and we've already heard this, but delivering against net zero, you need to think about the energy that's embedded in the resources that we use and the resources that often we waste, and to try to reduce the amount of waste that's going on and the amount of resources that are going in the first place. And this is also so important for delivering against sustainable development goals, and particularly thinking about the one around responsible consumption and production. But circular economy also underpins several of the other sustainable development goals as well, and is part of the UK trying to be a global leader in this area. So I'm just going to talk very briefly about the programme that this centre fits within, but Fiona Charnley will be talking later in far more detail. So this centre forms part of a £30 million programme that was funded by UKRI through our Strategic Priorities Fund. And this was a specific fund set up to increase collaboration between disciplines, as well as delivering on strategic government priorities. And UKRI are running this programme in partnership with DEFRA and BEIS. So government support is integral to ensuring that this programme has success. And we are aiming to accelerate understanding and solutions to deliver more circularity. So while there's a lot of fundamental research going on here, it is important that it's working towards delivering actual solutions that can be implemented. We also want to coordinate the activity that's going on across the UK, share that knowledge, and in particular ensure that it's always being embedded with stakeholders in mind. There are 6 of the UKRI councils who are involved in this programme, and that is to ensure that that interdisciplinarity is being achieved, as well as working between the research councils and Innovate UK to make sure that we're seeing that pipeline of activity from fundamental research through to innovation and through to industry. We funded 5 centres, this being one of them, as well as an integration hub to bring these activities together. And we'll also be funding some collaborative research and development opportunities later in this year for small and medium enterprises to engage with the work going on in the centres. And again, this is to ensure that it's being embedded in industry, the solutions that are coming out of the fundamental research from the centres. And we then link up to a range of stakeholders. The Chief Scientific Advisor of DEFRA sits on our Strategic Advisory Group, and we'll be hearing later from Professor Paul Monks, the Chief Scientific Advisor of BEIS, so we can hear about the links to their activities as well. There were a number of features we asked for the centres to do, and I have to say there was a lot of competition for funding for centres, and it's a testament to the sort of team that's been put together for centres such as this one, that they got the funding given how much interest there was. So all of the centres have set up an interdisciplinary group. So the aim is thinking as a whole system. So not what's going on over here and what's going on over there, but trying to influence each other and make sure that we're considering what's happening across the supply chain and thinking about the ways that we can deliver the best possible solutions. Industry engagement is key. And across the programme, we've identified £12 million of leverage from industry. And a lot of this is building on existing collaborations that were going on between universities and industry partners. But a lot of new industry partners have also been brought in, which has been really good to see. And finally, the importance of this policy point across central, but also devolved and local governments, and trying to ensure that the solutions that are coming out of this research can be embedded in policy going forward. And we have a number of impacts we want to see from this for academia, for industry, but also for society as a whole, and making sure that society has the information they need to make more informed decisions as consumers. So that's all from me. I look forward to hearing the rest of the talks as the day goes along, and good luck with the rest of the centre as it progresses.
Thank you very much, Nick. So those who are joining us, that was Nick Cooper, Interim Head of the Circular Economy, EPSRC and UKRI. And I'd just like to say that there are questions coming in. How as participants can you join in? We really want to hear your questions, and there's various different discussion sessions and panel sessions scheduled for the rest of today. But can you put your questions in the chat? I can see that already Anne Velenturf and David Peck and Tamba Contek are all doing that. Thank you very much. Do put your questions in there, and we'll get to them in those panel sessions and try and sum up around them. So please, yes, please, to your questions. As they come into your head, put them in the chat. Thank you very much. Now I'm going to hand over to Professor Fiona Charnley. Now, she is co-director of the Circular Economy Hub. As you heard from Nick, this is a crucial hub within the UK strategy for trying to knit together different material circular economies and make sure that they all are moving towards the same goals. And I'll hand over to Fiona now. She is a co-director, as I said, of the Circular Economy Hub and at the University of Exeter. Fiona.
Great, many thanks, Mark. Good to be here. I'll just share my... Is my sound okay?
It's a bit fuzzy, actually.
It's not sure why that is. Just give me a second.
Is the volume up? Sometimes there's a bit of feedback from the mic.
Yeah, is that any better?
Yeah, that's better.
Yeah, okay, great. There we go. So should be able to see that. Brilliant. Well, thanks ever so much, and thanks for the invitation to come and talk about this really groundbreaking and exciting programme, as Nick has just outlined. So myself and Professor Peter Hopkinson are co-directors of the UKRI Circular Economy Hub, which, as Nick mentioned, aims to bring together and add value to the programme as a whole. So I'm going to give an overview of the programme and also some of the activities that the Hub is leading on to ensure that we do that. So, as mentioned, the National Interdisciplinary Circular Economy Research Programme is the largest UKRI investment to date that focuses on circular economy research. And the £30 million investment is split across 5 national interdisciplinary circular economy research centres, of which this centre is one, each of which focus on a particular resource flow, and then also an integrating circular economy hub that aims to coordinate, scale and add value to the programme as a whole. The programme also includes £2.5 million worth of Innovate UK funding, focusing on SME research and development, and this will be announced later on this year. And importantly, as Nick mentioned, the programme is supported by all UK research councils and has significant support and involvement from the policy community, including DEFRA, BEIS and other devolved administrations. It's a 4-year programme that's just been launched in January this year, and initially it consists of a significant number of stakeholders. So as shown on this slide, 34 universities, 64 senior academics, 42 early career researchers and over 60 PhD students, an initial network of 120 industrial partners. However, a key aim of the programme is to grow the circular economy community through a significant programme of outreach and collaboration that I'll be detailing later on. So during the process of developing the proposal for the hub, we had 9 months of undertaking some consultation across the funding landscape, so existing grants. We reviewed the policy landscape, and we also consulted with a number of circular economy stakeholders across the community, including an extensive industrial survey to better understand what the requirements of this community were aspiring towards a circular economy for the UK and beyond. And what we found was that there was a lot of activity already underway across the UK and beyond. We learned from significantly from international players as well. But what we found was that there was a real lack of clear guidance on the definitions, terms and principles and some of the methods that underpin the circular economy. There was also a real need for more kind of inspirational case studies that were underpinned by scientific evidence and academic rigour. And also that there was a need to coordinate and empower and mobilise citizens and stakeholders associated with the circular economy to really bring about that systems level change that we need. And so as a result of that, the hub consists of a research programme of 4 key research streams, each of which is cross-cutting to the programme. So the aim of these all 4 of these work streams is to coordinate and upscale the work of the 5 centres and the programme as a whole. So the first work stream is to develop a dedicated circular economy observatory, which will create a systemic data and modelling approach for the NICER programme. The second of these work streams will be to develop a circular economy knowledge platform, which aims to consolidate and synthesise outputs coming from the NICER programme, but also the wider UK and international knowledge base. Thirdly, we'll be facilitating mechanisms of interdisciplinary and cross value chain collaboration, contributing towards the co-creation of a UK circular economy roadmap. And then finally, the 4th work stream aims to build and coordinate an inclusive circular economy community. So we really want to enable and empower collaboration between diverse user groups in order to address the longer term circular economy capability and skills gaps in order to inform future investment and training opportunities. So I just wanted to go into each of these in a little bit more detail. So the aim of the National Circular Economy Observatory is to create a systemic data and modelling approach for the UK NICER programme that enables data from material flow analysis to be aggregated at different scales to inform industrial and governmental decision making and also the national and global agenda and strategies. So this will initially involve collaboration between the 5 centres, the hub and other key stakeholders working in resource flow modelling to map and evaluate existing activity and data and knowledge. And we've already started doing some of this work through the development of a data cluster, which involves representatives from across the centres, plus other key stakeholders. And we're organising a 3-day design sprint in June to develop the underpinning framework that will lay the foundations for the observatory. So we'll work with the centres to identify a number of signature products from each of the resource flows or centres to demonstrate the physical flows of materials and opportunities for additional value creation and capture the metrics that are required to track and measure progress on this. So just moving on to the knowledge platform. The aim of the knowledge platform is to consolidate and synthesize the NICER programme outputs and key examples of knowledge creation from the wider UK and international knowledge base to provide that important single point of reference for the UK. So the knowledge platform will be underpinned by an evaluation framework to measure the real effects and impacts of the different tools and approaches and knowledge that is being developed. We've already started some of this work by working with the centres to review, map and critically evaluate existing and emerging knowledge across the academic, policy and industrial landscape. And we're working towards the development of a common understanding of circular economy principles and practices for the NICER programme to then inform the wider community. So as I mentioned before, in addition to the research programme, we've developed an extensive outreach and engagement programme to maximise the impact of the programme as a whole. And this is split across a number of different activities targeting 3 different key stakeholder groups. So phase 1 of this programme is really to engage excuse me, with the 5 centres and the hub and their research communities and effectively communicate the outputs and outcomes of the programme to that wider community. So key aspects of this include a national launch, which is taking place between the 24th and 27th of May. And so we're happy to circulate, obviously, information about this after this event. We'll also be undertaking an annual symposium, which will involve an end of year 1 report that really provides the evidence that the 5 centres have brought together to demonstrate the size of the circular economy opportunity for the UK specifically. And also we'll be developing a training platform to support the 100 plus early career professionals that are associated with the programme and community. Phases 2 and 3 of the engagement strategy aim to engage the wider circular economy community, so circular economy collaborators, experts, end users, and also the wider citizens and society. So elements of this include the launch of a £500,000 flexible research and innovation fund that will be launched later this year to fund a number of demonstrator and feasibility projects to enable collaboration between the NICER programme and the wider community. We've also initiated a number of cross-programme clusters focusing on particular cross-cutting themes such as data and policy. And we'll also be developing a national roadmap. And then in stage 3 of the strategy, we'll be running a number of events, including webinars and also local, regional and national stories from across the circular economy community that demonstrate the fantastic work that is already taking place in a number of different regions across the country. So finally, just to demonstrate some of the management and governance of the hub and how it relates to the wider programme. So we obviously are interacting with the centres on a daily basis, and we have our own executive management group that then reports into the UKRI Strategic Advisory Group that Nick mentioned before. And then the mechanisms that we've developed for engagement across the centres and the wider community feed into that executive management group. So thank you very much, and wish the Circular Metals Centre all the best of luck over the next 4 years.
Thank you very much, Fiona. That was Professor Fiona Charnley, who's co-director of the Circular Economy Hub at the University of Exeter, who's coordinating the circular economy research in the UK. And there's lots of questions coming in, Fiona, about how to get involved with the hub, and I'm sure there will be more on that. In this event that we're doing today, we're going to show you how to get involved with the Metals Hub. And so for those who are asking about that, please do keep tuned. We'll get to that, but keep your questions coming, please. They're excellent. And it really helps us understand what we're communicating well and what we haven't communicated yet well. So thank you. Questions in the chat as they come to you. Now, I'm going to hand over to Professor Fan. He is Director of BCAST at Brunel University. He is the mastermind behind this centre. He is the person who first sent out the hand of opportunity to all of us involved and is continuing to lead the centre in a masterful way. He's principal investigator and director of the UKRI Interdisciplinary Centre for Circular Metals, and he is the current director of BCAST at Brunel University. Professor Fan, I'm handing over to you.
Thank you very much, Mark. And Matt, I need the slides. Okay. Good morning, everybody, and welcome all the friends from far away. And my name is Zhongyu Fan, as Mark introduced. I'm the PI, the principal investigator of Secular Metal. Secular Metal is a program, collaborative program between Brunel University, UCL, and Warwick universities. And it's funded by UKRI and through the NICER program. And you can see at top here is our logo here, the full name, UKRI Interdisciplinary Center for Circular Economy, for Secular Metals. And for short, we got a short name called Secular Metals. And just for your information, if you use full name, it's Secular Metals. And it's just short name, one word, Secular Metal without S. In the next 10 minutes or so, I'll give you a very brief introduction. Thank you very much for all the previous speakers, Julia, Nick, and Fiona, to set up the background for this center here. Can you go forward? Okay. Resource consumption here, okay. The Earth has been there for 4.5 billion years. And human being arrived on this planet only about 200,000 years ago. But human being has made a big splash on this planet. And particularly last 200 years after Industrial Revolution, and the resource consumption changed from secular manner to a more linear manner. And more important, after Second World War, resource consumption becoming exponential. And as you can see from this diagram here, after 1945, there's an exponential growth of resource consumption, which coupled with fast GDP growth and followed by some degree of increase of populations, okay? So we need to see why we are doing this. Can I have next slide? This linear resource flow, and it's causing us big problems here now. And as the previous speakers already mentioned here, for a long time, the planet we are living in is almost circular. And in the last 200 years, we take huge amount of resource from Earth and to fuel our economy by making different things. After usage, most of them becoming waste and deposited back to the planet. So what we are doing, basically, we're undermining the planet and as an ecosystem. The ecosystem is shrinking by size, by volume, and our local economy, human economy is growing. So there's a head-on collision between the shrinking nature and our human economy. The consequence of this is our global ecosystem is shrinking and losing its power to sustain life. The next slide, the deeper reason for this is how we position ourselves to nature. For a long time, we arrived on this planet, we are feared of nature, so we worship nature. And after the Industrial Revolution, we start to change our mind. We think we position ourselves as master of nature, and our aim is to conquer nature. That's how we develop into this linear way of thinking, linear way of economy. We take, we make, we use, we deposit. Regardless of the nature's ability to regenerate, and regardless of the need for future generations. Next slide. Now I'll take an example. Most of you may be familiar with steel making process. This is a typical example of linear technology as an outcome of linear way of thinking here. And to start with, you have mineral mining and processing and utilizing carbon to reduce iron oxide to produce liquid iron, which is quite often called pig iron. The pig iron, because you use the carbon to reduce, the pig iron saturated with carbon, about a few % of carbon there. And it's very brittle and much less usage. So in order to get rid of carbon, what we do, we blow oxygen into the liquid metal. That's very famous, the oxygen converter, and invented in this country, Sheffield, about 200 years ago. Okay. With this process, the oxygen is reducing the carbon inside the iron, liquid iron, but the oxygen contents in the iron is increased. And then what do we do next? We use deoxidation process to put aluminum or magnesium in to reduce our oxygen contents. But the consequence is we got more oxide inside. They are normal nanoparticles, very difficult to get rid of. So now we're going into the next stage called refining process. The refining process, we also learned the steel making process in universities. And there was over 100 different types of techniques to achieve refining of liquid iron, liquid steel. So you can see the problem. It's a linear way of thinking. We try to resolve one problem, but at the same time, it creates a bigger problem for next stage to resolve. Of course, in the future, of course, we need to rethink how we do our science and technology and change our way of thinking. Next slide. Circular economy is just very recently, last 5-6 years, the circular economy research becoming very, very popular. And as the number of publications increasing exponentially here, which promise to provide a solution to our unsustainable world, okay, we are living in. So circular economy, by and large, is aiming at rapidly to reduce or eliminate extraction of raw materials or production of waste here. And next slide. But in general sense, in broader sense, circular economy goes well beyond economy, and which first thing is philosophy, which defines our position in nature. And as I mentioned before, we position ourselves as master of nature is under the linear economy. And circular economy, we should position ourselves as friends of nature. Of course, it's an economy. With this circular economy, all the economic activities has to be bounded by the nature's ability to regenerate. And in research, for the research community, circular economy means we offers us a great opportunity to rethink our science technology, how we develop our science, how we employ our technology as well. And for government, and very importantly, without the strong government intervention, it will be difficult to achieve circular economy. And the transition from linear to circular cannot be achieved without a strong government intervention, which roughly is old terms called visible hand versus invisible hand, which is free market economy. And because free market economy, the whole goal is to enlarge profit. But under circular economy, the objective is to protect the environment and to make the economical development more sustainable. And of course, manufacturing, we need to design products to be high quality and long lasting for society, which means a harmonic society which cherishes equality, diversity, and inclusivity. So for future generation, circular economy means a better planet. Of course, there's a lot more. Next slide. Now, circular economy as a research discipline, it just started not very long ago. All this concept might be in different forms for a long time. And here I just listed 5 very basic principles. And it sounds very complicated, but in terms of very basic principle, it's easy to understand. And the first principle is live in harmony with nature. And as I already said, we need to position ourselves as friends of nature, not masters of nature. The second principle is waste as resource. And all the materials, products, and need to flow in a closed loop. Resilience through diversity. So this is a wider sense. This applies to everything. And a scientific world and it's a biosystem is a system with multiple components and more resilient to challenges, to change. We need to use energy from renewable source. And of course, we need to think in a systemic manner and a holistic thinking rather than is a linear economy, we think a single factor. And next one. And our long-term vision and for our center here, based on the circular economy principles, and we aim to achieve full metal circulation. And under full metal circulation, the global demand for metals is met by secondary metals through reuse, reduce, reuse, remanufacture, recycle, and recovery. Of course, this means no more mining and no more metal extraction. Next one. Circular metal, our strategy in our research is we aim to deliver full metal circulation through closing loop, narrowing the loop, and slow down the loop here. And what I'm showing here, through these 3 approaches, we have set up a number of research areas, which is shown by the circles around the metal flow here, and which including circular alloys and circular technology and circular macroeconomics, circular pricing and policy, and circular society. Of course, we should also include circular supply chain, circular business models, and circular product design. So these are interdisciplinary research areas, and so much needs to be covered. And the next one, but we only have 4.3 million pounds to start. We are lucky to have this starting point, but we cannot do everything as we set up in these areas. So what do? We set up projects in specific strategically important areas to reflect the intertwining and 5 socio-economic facilitators and 5 technological enablers, as shown here. As technology enablers include reduce, reuse, remanufacture, recycle, and recovery. And socio-economic facilitators, which including design principles and business models and a sustainable supply chain, macroeconomic, macroeconomics, circular policy, and circular pricing. Of course, we need to have circular society. Next one. I have here, just very quickly to illustrate, we have 2 examples to illustrate our ideology to do research here. The first one is circular alloys, okay, and which is a typical example of circular approach to the future alloys. And historically, all the metallic alloys is developed by a very much fixed way. We select a metal, which normally we purify the metal, and then we add some other elements to improve the mechanical or physical performance of the alloys. By doing this, and also through free market economy, and everybody want to have their own alloys, minor changes of composition, processing conditions, but lead to different grades. So we end up with thousands of grades of metallic materials around the whole world. And these metallic grades normally are not resilient to changes. And for example, metals theoretically supposed to be recycled infinitely. However, in reality, the metallic alloys cannot be recycled directly. For example, aluminum alloy, and when you recycle, the mechanical performance is very much degraded. You have to do lots of treatment and processing before they achieve better performance here. So the future alloys, and of course, need to have higher performance. I mean, higher performance, we are not talking about 10%, 20% increase, and it should be orders of magnitude higher performance. And they should be repeatedly recyclable and service much longer. Not only have one life, they can have many lives, okay? And in our research, we are searching for a specific multi-principal elements composition space. Multi-components here with me is not 5 or 6. We're talking about 10, 20, 30 elements. There's no principal elements. They're all equally important here. And by doing this, in the future, we only have very few grades of high performance materials. Next one. Next one, I want to see, okay, what's our idea about the future? In the future, how are we going to use metallic materials here? And the circular economy, and metals being extracted and being made into components, and components put into specific devices for applications. And after usage or breaking or damage the metallic components, and we threw away or recycled here. That's how we treat metallic materials, metallic components here. One fact we need to bear in mind, metals are similar to human being. They get tired, so-called fatigued. And after prolonged service, metallic components get fatigued. But we never ask how they feel and how they perform. Is any need for recovery after fatigue? And in the future, we aim to develop similar to the National Health Service is the UK NHS. We try to develop a mental health service called MHS, and which to change our way to use metals from a slavery approach to a partnership. A partnership means we look after metals and they can serve better our purpose, okay? So the metallic mental health service, which include, we will develop component health record and regular performance monitoring and regular rejuvenation treatments like human being. We have, after working for a while, we have regular food, drink, and sleep. And metallic components should be treated a similar way. Metal clinic for minor damages, and also we develop hospitals for serving metallic components with the have major damage, okay? By doing this, the metallic components, once being made, they can be utilized many times, many lives, and a much longer life. And if a person work continuous without food or drink, we may not even last few days. If we have regular health service and we live for 100 years. The similar metallic components, if we look after through MHS, they should be lasting much longer. Next one, last one. So we are lucky placed to have circular metal program, and we're very grateful for the funding, and we are very grateful for the industrial input as well. But what we can do is very little here, and we need to deliver first mass circulation. We need everybody. We need every stakeholders. We need all sort of actors to participate in our program. So we welcome you to join us for a long journey ahead. Thank you.
Thank you, Professor Fan. That's great. And just want to say, I mean, that was Professor Fan, who's director of the Circular Metals Centre. And just to say to all those in the who are putting questions in the chat about our research program and what we're going to be doing over the next 4 years, that we really want to collaborate with all of you. We're very open to collaborations, and please do log on to www.circularmetals.org.uk and register on the contact page there if you haven't already. We want to work with all of you. There's so much work that's gone on prior to this, so many companies, so many researchers who your work is extremely relevant to this, and we want to connect with you. So now, without further ado, I want to move on to Professor Paul Monks, who's Chief Scientific Advisor to BEIS. BEIS, for those of you around the world, is a government department here in the UK charged with business, economics, industry, and Professor Monks was Pro-Vice Chancellor and Head of College of Science and Engineering at University of Leicester before he became into his position at BEIS. So he knows how research is done. He knows how to connect with universities. I'm going to hand over to you now, Professor Monks.
Thank you very much, Mark, for that. Can you see my slides and hear me?
Yes.
Wonderful. Thank you very much for inviting me to the launch of this centre tomorrow and to give a department perspective from a chief scientist in a government department. A government department that thinks the circular economy and metals are incredibly important. So I'm going to go out a little bit. I heard the last presentation. I'm going to go out a little bit and go out from where we start on this and kind of head back into the circular economy and metals a little bit more. For us, one of the biggest challenges that society faces over the next period of time is the challenge put by net zero. And for those of you who don't know, in 2008, the UK was one of the first governments in the world to set an ambitious goal for the reduction of greenhouse gases, and that was being modified more recently, and we've legislated to reduce our greenhouse gas emissions to net zero by 2050, which is essentially a 100% reduction compared to 1990 levels. And that's very much embodied in something called the Climate Change Act. But also we issue a series of carbon budgets, and we're just about release a 6th carbon budget, which I'll get to in a moment. They're also very much part of the international effort as part of the Paris Agreement and the COPs. And of course, we'll be hosting COP26 in Glasgow later this year. And we've recently just published our what's called nationally determined contribution, which is a very ambitious level for the reduction of those greenhouse gases. As I said, we've got the 6th carbon budget, which has promised to reduce by 78% the carbon emissions by 2035. And I think that really, in some senses, why am I talking about that? Because this frames this question of the circular economy, because we're going to need low carbon energy supplies, we're going to need low carbon solutions, we're going to need less carbon intensive activities. We're also going to be able to, it's going to be important that we reduce agriculture as well, or change the way that we do agricultural emissions at least anyway. So to carbon budget 6, this is just one of the pathways from the recent report, and I know you had some very eminent speakers who know a lot about this very early today, but there are different types of pathways to that net zero. But I think there's 2 elements that are in that long list of 6 things on the right there. We need to reduce demand, and that's for electronics and vehicles and the like, but also we need to improve our resource and material efficiency. And as you can see, they are important elements in achieving net zero in this balanced pathway by 2050, as well as an array of other low carbon solutions as well. So really this demand and resource and material efficiency is absolutely critical and central to the vision of net zero. I think you've had this already, but we've just, as a department for Business, Energy and Industrial Strategy, produced this industrial decarbonisation strategy, which really talks to the heart of this. That talks to these questions around industrial efficiency and material substitution and the support of resource efficiency and the circular economy model, including that increasing of reuse, repair and remanufacturing. That moving away from that linear model, I think, is important. One thing I think is always very important to think about when we talk about net zero and you talk about the circular economy, we've not got to imagine this is solely a technocratic solution that can be reached by just solely deploying technology. In the Carbon Budget 6 produced by the Climate Change Committee, who advised the government on this, they made the point really strongly that you've got to get the societal and behavioural pathways to net zero working together. And that is very much in some of the issues around the circular economy and metals and recycling. You've got to choose products that last longer, but also you've got to choose products that can be designed to recycle. And that's a real challenge in when you're trying to drive efficiency as well as reusability at the same time. So I think as you sit here today and you think about some of the technological solutions that you'll be thinking about in the centre, I challenge you also to think a little bit about the behavioural wrapper that goes around this and the way that we're also going to need to change our behaviour to meet net zero. There's no doubt that science is a critical part of this. And I take this from a recent report that we as a department wrote. Beyond the immediate imperative to overcome COVID-19, the greatest challenge facing the UK and the world is that of decarbonising our economies and building resilience to the impacts of climate change. And for me, that brings us to the paradigms of sustainable net zero, understanding about critical materials, security, supply and recycling, that end-to-end approach of looking at that. On the right-hand side is a periodic table scaled by the availability of the elements on Earth, showing that we've got an issue around critical materials and the role that science is going to have to play, but also the importance of recycling and security supply in that. We've also got to treat this as a resilient net zero. We'll make challenges, we'll make changes as we go along, but also it's a systems of systems approach this. You need a systems approach to this. So I think I would challenge you also to put your centre in a systems thinking type point of view as well with respect to the circular economy, because I think undoubtedly you all know that it is part of a system of systems. It's about technology, it's about behaviours. I do wonder also whether we can gain economic advantage from approaches towards this as well. As a business department, I'm virtually obliged to say that in passing. So science is absolutely core to the delivery of a vision of net zero and the circular economy. I think, and you've seen pictures like this already this morning, I think we can think of a circular economy as an industrial system that is restorative by design. This is some work done by EPSRC and the Ellen MacArthur Foundation that you're probably familiar with, looking at the minerals manufacturing cycle on one side, but the renewable energy and power side on the other, and thinking about how to get those to couple. And in a way, it's to my point a little bit around a systems of systems approach. I think my one final comment about science before I finish the talk is also the role that digital twins can play in this. And this, I think, is a very nice example. And I think it took the mental health service. I quite like that from the last talk, but I guess it's the same idea as the mental health service in some senses. Can we have digital twins that enable this? It's again an example from the EPSRC portfolio, where the digital twins learn about the performance here of a battery, and therefore we can understand how to reuse that in a way. I think that harnessing of the digital understanding alongside also the functional understanding of these materials is really, really important. I guess that's the concept in the mental health service that we just heard about. So really kind of bring these sort of ideas together. Digital is a key part, in my mind, of that. Just one more final comment on the sustainable supply from recycling. I think this is a graph that I was shown last week that struck me around the primary and secondary use of this is just of batteries and the recycling gap that arises from that. So there is a time lag in that system as well. So I think we've got to understand and be realistic about what we can achieve with elements of the circular economy versus the primary production of materials and the time lags that will be inherent in the system as part of that. But again, I think it's trying to understand that systems of systems approach and that sustainability alongside that circular elements of a recycling economy. So hopefully that kind of big picture perspective down from net zero down to the circular economy provides a perspective that I hope the centre will be able to respond to. I think, as I said, achieving net zero and mitigating climate change will require this kind of systems of systems approach. We will require increasing resource and material efficiency to drive that circular economy. And I absolutely believe that science is critical to this, a combination of the research and development, the technology and the behavioural sciences that will be needed to pull together this transition to net zero. So thank you very much for inviting me. And I've already tweeted about your launch today, which I wish you all the success with this centre, which is very, very much needed and very much an important area of trying to achieve the challenges of net zero and those of the circular economy. Thank you very much indeed.
Thank you, Paul. That was Professor Paul Monks. He's Chief Scientific Advisor to BEIS, the government department here in the UK. and very well-timed comments about society and a global. We're part of a global system here, right? And these global targets. And that brings us very nicely to Chris McDonald, who's CEO of the Materials Processing Institute, because really we are part of a global supply chain. Steel, aluminium, and all the other metals are all part of global supply chains, and connecting in with those is absolutely vital. So, Chris, over to you, CEO of the Materials Processing Institute.
Thank you, Mark. And it's really a pleasure to be here. And I'd like to also thank Professor Fan and the team at Brunel for inviting me to speak to launch this really, I think, vitally important new UKRI Interdisciplinary Centre for Circular Economy in Metals. Now, my background's in steel, and in fact, I've spent my entire career working in the metals sector. And during that time, I've had the great pleasure to get to know Professor Fan and to appreciate the tenacity with which he's built a great capability at Brunel, which started first in light metals and is now focusing on the circular economy. And so I think all of us who are active in metals technology and research in industry, as I am, are grateful to Professor Fan and to Brunel and UKRI for their ongoing commitment to research in this really vital area. Now, as Mark's just mentioned, I'm the Chief Executive of the Materials Processing Institute, which is the UK's national centre for the development and scale-up of new technologies for the steel and metal sector. At the Institute, we have 4 areas of research interest: advanced materials, digital technologies, industrial decarbonisation, and of course, the circular economy. And as we've just heard from Professor Muggs, it's possible to combine some of these things together. So as we look at decarbonisation, the circular economy, we can also see how advanced digital technologies can enable that. Now, just as Professor Fan and his colleagues carry out fundamental early stage development activity, it's our job at the Materials Processing Institute to do the upscaling innovation, the commercialisation that brings this great investment in research through to its economic potential in industry. To support this, the Institute was recently awarded £22 million of funding by the government through Innovate UK, which is part of UKRI, to support the UK steel and metal sector. And this is now available for us to work with UK-based companies. So in this way, this new centre for the circular economy fills a vital gap in national capability by building on our existing strong relationship and working together. So Brunel and the Materials Processing Institute combined represent a really powerful set of capabilities that will enable us as a United Kingdom economy to take research ideas all the way from a fundamental stage right through development and application in partnership with industry as never before. Now, I'm also the chair of the UK Metals Council, and this is the body that links 11,000 or so businesses in the UK metals sector directly with government and with one another. In this role, I've seen just how important an industrial sector metals is to the UK. The industry directly employs 250,000 people, with another 750,000 relying on it. The sector makes a contribution of almost £11 billion per year in GDP, and yet very few metals industry companies are household names. There are 2 reasons for this. First, many businesses in the sector are small businesses. They're important in their local communities. They may have highly specialised processes such as advanced casting, forming or coating, but they rarely garner national attention. The second reason is that metals businesses are vital linchpins in our industrial supply chains, but they don't make consumer products. Instead, they make the materials or the components from which household names make their products. And it's for this reason that the health and sustainability of the UK metals sector is vital for our advanced engineering, rail, aerospace, and automotive sectors. The green industrial revolution, as we have heard, will be built on metals-intensive technologies, such as offshore wind, nuclear electric vehicles, and more. So why is it then that a circular economy centre is so vitally important to the UK metals industry, and as a consequence, to the UK economy as a whole? Well, there are several clear reasons why the circular economy presents a major opportunity for the UK metal sector. The first and perhaps most apparent is one of environmental sustainability.
and resource efficiency that meets Britain's ambition to be a global leader in decarbonising technologies, and where my institute is also thinking in terms of our role to support the UK's hosting of COP26 in Glasgow later this year. Utilising recycled metal means that less virgin ore needs to be mined. This much is obvious. And it creates an environmental benefit at the mine. But there is also an environmental benefit from the processing, with less energy generally required for recycling rather than smelting and refining. But this does present a series of research questions that need to be answered around the recyclability of different metals, the technologies for sorting and separation, as well as an understanding of the product and applications performance where products are made from recycled materials as compared with virgin ore. There's a second opportunity in the reduction of mining, in that some metals are sourced from locations around the world where the proceeds of the mining industry are used to prop up undemocratic and exploitative regimes, where workers are poorly treated, child labour blights the lives of millions, and modern slavery also persists. For too long, Western consumers have been able to turn a blind eye to the consumption of materials produced overseas in ways that would not be acceptable at all. A circular economy approach gives the opportunity for consumer and producer choice and competition, with the opportunity to drive up ethical standards and the working conditions in the materials supply chain. This reduction in our reliance on international material supply chains is also an important consideration for our sovereign security and capability. At times of increasing geopolitical tensions, and with the security of material supply seen as vital to national interest, it's worrying to see how many metals vital for our future are now listed as having a supply risk. If anyone doubts the vulnerability here, we saw recently with the blockage of the Suez Canal how quickly international supply chains can empty as just-in-time deliveries dry up. Investing more in our circular economy will provide a degree of resilience to UK manufacturing and infrastructure projects, as well as reducing our political dependence on interests that dominate the production of certain metals. Increasing the circularity of metals is also vital for delivering the green industrial revolution. New green technologies, whether for electrification, energy generation, or associated infrastructure, all need metals. It's also true that as we seek to eliminate carbon emissions, not only are we investing in renewing our manufacturing base and adding new infrastructure, but there's a strong environmental case for metals to be favoured above other materials, such as cement, for instance, where this is possible. As a consequence, the drive to eliminate carbon, whilst it might result in greater materials efficiency in the long term, will also result in a short-term surge in materials demand and a greater shift towards metals within that. Where metals will have a challenge is ensuring the recyclability of ever more exotic alloys to create the properties for new green applications, for stronger, lighter, more conductive, more hard-wearing metals, or with enhanced coatings. Again, this is an important area of opportunity for the UK metal sector and presents a vital set of research questions for the new Circular Economy Centre to address. My final point on the benefits to the metals industry in achieving a circular economy approach is that in going green, we inevitably need to go smart too. The UK economy as a whole has stagnating levels of productivity since the financial crisis. But we're now seeing the emerging new digital technologies of the fourth industrial revolution moving out of the laboratory and on to the factory floor. Investing in a circular economy approach within the sector gives us the opportunity to simultaneously invest in automation and new ways of working. So go smart and go green at the same time, driving up productivity and increasing the sustainability of the sector and the jobs and the communities that rely on it. It can be understood from these areas of supply chain security, sustainability and ethics, increasing productivity and achieving a green industrial revolution, that the opportunity for the circular economy is of direct benefit to the metal sector, but also presents far-reaching opportunities for the wider UK. It is, though, useful to understand that this country, the UK, is almost uniquely placed to benefit from this circular economy approach. Having been at times the most industrialised nation on earth and having retained a strong manufacturing economy with advanced supply chains, This means that we have an abundance of available raw materials combined with the industrial base capable of utilising it. We must also recognise that to make this a success will require our talented researchers, engineers, industrialists and innovators at centres such as this, at my own institute, and in our excellent foundries, forges and furnaces throughout the whole of the UK. It's by working together in partnerships, such as those represented by this centre, that we can reap the benefits in industry, in developing key technologies for the future, in our communities and environmentally, of a circular economy approach to metals. So I'd like to thank you for your attention. If you're interested in what I've got to say, I've got a YouTube channel where I've posted a number of videos around the circular economy. You can find that quite easily, hopefully. Thank you once again to Mark and to Professor Fan, and I wish you the best of luck in the formation of this new centre.
Thanks, Chris. Looking forward to working with you on this. That was Chris MacDonald, CEO of the Materials Processing Institute. And Chris brought up an important point, which takes us to the next phase of this presentation, which is where we really talk about the research that we'll be doing. I can see in the chat and in the questions that there's lots of questions about the exact type of research that we'll be doing and in what sectors. And we have three speakers from the core team. Professor Brian Cantor will be up first, talking about circular metal and metallurgy. Then we'll have Professor Jan Godsell on circular business models. And then we'll have Professor Raymond Bleichowitz on circular macroeconomics. And that will give you a flavour. I mean, it'll only be a flavour, I'm afraid, of the scope of this centre and what we'll be doing. So first, I'd just like to hand over to Brian. Brian is Deputy Director of this centre, but he's also a Professor of Materials at Oxford and at Brunel Universities. And Chris talked about the difficulty of these high alloy metals and recycling them. And Brian, well, he invented high entropy alloys, as I understand it, and I think he'll be able to talk a little bit about that challenge of having very high alloy content and yet still getting good properties. Brian, over to you.
Thanks very much, Mark. Just going to share my screen as usual. And I hope you can see that. Is that okay?
Yep.
Good. Well, hi, everybody. Great to see you all. Well, I can't see you all, but great that you're all here, and perhaps you can see a small picture of me. My name is Brian Cantor, as has already been said. I'm a senior advisor at BCAST at Brunel University London. I'm also deputy director of the new UKRI Centre for Research, Interdisciplinary Research in Circular Metals, or to give it a short name, as Professor Fan pointed out, Circular Metal. I'm going to talk about the technology aspect. So there's two overarching points. First, the first one is to say that we have three broad strands of research. There's the technological development. This was somewhat prefigured in what Paul Monk said. We have the technology developments. He pointed out we can't cope with technology development alone, but we can't cope without it either. So there's technology development. There's development of business models and supply chains. And there's development of macroeconomics and socioeconomic activity by people. And so my two colleagues will talk about those latter two things after I've talked about the technology developments. The second overarching point is this, and it's come up a lot in the chat room. But it was just said by Mark, we're open to collaboration. We've got a significant sum of money, but way below what's needed to do what we need to do for this enormously important field. I'm going to say a few words about a few of our initial research work packages. It's only a selection of them. It's only to give you a flavour, and I'll say a few words about them. But we have more than this, but it's still nowhere enough. We are open to collaboration with everybody. So please contact us, because we intend to use the centre as a seed calling activity to initiate a lot of other research. And this whole launch is designed to get people to contact us so we can build more research. So let me go through some of the research we are launching with, just some elements of it. Here are some of the work packages. Multi-component alloys has already been mentioned by Professor Fan. Rationalization of steel and alumina alloy grades. using grain refiners to be able to use casting as opposed to wrought alloys, which involves less use of less material. Rejuvenation, of course, of materials. That's a little bit like the health service idea that Professor Fan mentioned. We've got some specific projects on, in this case, remanufacturing the big steel components used in heavy goods vehicles. Advanced sorting of scrap, already mentioned by Chris McDonald. And of course, with the massive growth there's going to be in already is and will be even more so in electric vehicles, new types of scrap and new needs to use scrap. So those are some of the elements. I'm going to go through them, some of these in a little bit more detail, but not very much. I'm not going to talk through these slides because there's not far too much to talk about. Just to give you a little bit more of a flavour, and please follow up. Get in touch with us if you're interested in these things or things which are in the interstices between them. So, as Mark already said, I was involved in inventing the field of multi-principal elements. There are two people who invented it independently some time ago. And it's been discovered now that if you have alloys with large numbers of alloying elements in them, which we've never done before, then they are resilient to adding even more alloying elements. And you get even better properties than conventional alloys if you tailor them right. So we have a particular project here to apply this to recycling, which, by the way, was thought about 20 years ago when this field started, but has hardly been taken forward by anybody. We also have at BCAST lots of new technology recently developed by Professor Fan and his colleagues for how to control the nucleation during solidification. We're going to need to use more casting, partly to replace raw products because that uses less material, but we need to get better quality castings, but also because we need to recycle. And when we recycle, we don't want to recycle back to the smelter and treat our recycled scrap as just on a par with new ore. We want to, if we can just remelt it, that's a lot better. And the new methods of controlling the nucleation to keep the grain size small and to control the nucleation of undesirable intermetallic compounds is critical, and the wherewithal to do that has been developed where it needs to be applied. This is the health service idea that Professor Fan talked about. So we can use advanced monitoring and measuring techniques, sensors, to detect as fatigue cracks grow and develop in a material. This is rather like health monitoring that's already used in a number of places, notably aerospace industry, to monitor components, but this is at the materials level. So we can use advanced sensors to monitor the performance of material, detect it's beginning to change, and use advanced rejuvenation methods to heal it. In many cases, perhaps in situ, but certainly demounting it and replacing and/or rejuvenating it much more quickly. Similar sort of thing here. Here's a specific case of doing this with heavy-duty goods vehicles, where there's a project to take these with industrial partners and take the big steel components in this and use, again, advanced sensoring, advanced lifing methods to be able to rejuvenate, remanufacture, reuse these very large amounts of steel much more effectively. And we're going to develop computer-based vision systems for monitoring and for sorting, as well as the system management of scrap. And here are two last ones, which are about using, again, the same kind of thing in specific cases. Electric vehicles are beginning to use, this is the first time that extrusion, rolled sheet, and cast scrap has all been merged together. To do this for electric vehicle usage, to do this, you need to have, again, advanced sensing, you need to have advanced sorting, you need to have new alloy formulations so that you can do it. And a similar sort of thing in the aerospace industry for the alloy Aramet A20, using, again, a newly invented method of melt conditioning, using shearing to make sure you can get the right sorts of structure. So that's all from me, just a bit of a taster and a rapid run through, but we want your input. So please come and talk to us about those projects, contact us after the event, and also contact us if you've got lots of interesting things to do in between these, because there's an awful lot more things we can do, because we are meant to act as a centre for the growth of the community. Thanks a lot. Thanks,
Brian. That was Professor Brian Cantor talking us through some of the metallurgy and research that will be undertaken in the centre. And now I want to hand over to Professor Jan Godsell, who's going to be talking about the circular business model research. Jan, over to you.
Thanks, Mark. Matthew, are you sharing the slides or do you want me to share my own?
If you can share them, that'd be great, please.
Okay. Just a moment. Okay, so I see that there's been some very interesting points made in the comments that actually speak to some of the work that we're doing within Work Package 3. And one of the great things about Fan, when he was reaching out to people about the project, was the inclusive way in which he looked at this. And for those of you reading the comments, there's lots of you talking about that it's not just about the technology or the materials, but that this may require different ways of actually thinking about how we do business. And so actually, one of the great things, again, about this particular work package around circular business is that it actually brings together the strengths of two universities, Brunel and WMG, to consider this issue from three interconnected perspectives. So we're going to look at circular business model innovation, which perhaps answers the question that we heard earlier from Mike, who's sort of saying, if we're going to make these things last longer, are they not going to be more expensive? So how are people going to be able to afford them? So part of the way that that's going to be made possible is through having different types of business models, perhaps using servitization or lease type models. But actually what we want to do is, with some work led by Fabrizio, supported by Alessio Franconi at Brunel, is to understand that full spectrum of different circular business models and how they can be applied. And then we saw, actually, I think it was a different mic, so there's lots of mics on our call today, who was then asking the questions about, but what does this mean for supply chain design? This gives us an opportunity to do things very differently. And indeed it does. And that's where my area of expertise comes into place. And we'll be looking at the ways in which we can align the product, the process and the supply chain design to take that old principle of 3D concurrent engineering, but actually apply it to the circular economy, particularly in the metals industry. And then our colleague David Harrison from Brunel will then actually think about that in a lot more detail from a product perspective to actually pull out what those circular product design principles are. And so what you're going to see is a programme of work over the 4 years that answers a range of different research questions. So with that first package around business model innovation, we'll be answering questions such as, how can circular business models enable full metal circulation? What are those socio and technical barriers and drivers that could enable that successful transition? And how can these businesses be enabled by a range of those different design principles and tools to enable those circular business models to actually take place? From a supply chain perspective, we're going to be looking at those supply chain design principles. So this idea of 3D concurrent engineering, designing the product, process and supply chain simultaneously, is an old idea. And indeed, it absolutely pains me to see so many organisations just so focused on the product. And having a background in pharmaceuticals and working for Dyson in the early days, these were very, very product orientated organisations. Some think a little bit about the process, but there are very, very few organisations that think about their supply chain design from the outset. And so actually we think that in order to really make the breakthrough in terms of the circular economy, we do need to do that. And what we also need to understand is, therefore, if this is a really straightforward principle, why haven't people done it? So what are the barriers, drivers and enablers to adoption? And how can these actually help us to, by overcoming those, to accelerate the successful adoption of circular business models? And then last but not least, the sorts of research questions that we're looking to answer through the circular product design principles is to look at, if we want to align product, supply chain and process, what are the product design principles that we need to embed that are actually going to enable that to take place? And again, I think this is a common theme when you start to look at types of work where you actually want to drive change in the real world. You need to understand, again, those barriers and drivers, and also, again, this idea that we want to actually accelerate the adoption. So to bring these three sort of work streams to life, what we're actually going to do is to work on 3 case studies. And what you'll see, you can see that big JCB at the front there. So what you can also tell is that we're going to dovetail nicely into our colleagues that are working on the more technical work packages, and also our colleagues from UCL. I'm just about to hand over to Raymond in a moment, who perhaps are working at the more economic and social orientated work packages. But we're looking at 3 different sectors that we think show the full range of what we'd say is the sort of product process choice matrix. So at one end, we've got fast moving consumer goods that are high volume, relatively low variety, and actually do get directly into the hands of the consumer. In the mid sort of range, we've got yellow goods, the likes of a JCB, and at the other end of the spectrum, where we've got very, very high variety but low volume, we have the construction industry. And by actually working on real life case studies in these sectors, we will bring the research questions that I've just presented to life. Thank you very much.
Thanks, Jan. That was Professor Jan Godsell on our circular business model research. And as she alluded to, now that it's working in collaboration across universities, this centre. And I'm going to hand over to Professor Raymond Bleichspitz, who is going to talk about the circular macroeconomics modelling and research being carried out. Professor Bleichspitz is director of the Bartlett School of Environment and Energy and Resources at UCL, and he is chair in Sustainable Global Resources at the UCL Institute for Sustainable Resources. Raymond, over to you.
Well, thanks, Mark, for your very kind introduction. It's also glad to see like 2 UCL people, at least now for a few minutes, being here on the screen. Raymond Bleichspitz, Chair in Sustainable Global Resources and Director of the Bartlett School. So I thought what I could share here feeds into what we have discussed over the morning, and you probably can see my slide now, right? So it is very much about the idea.
It doesn't look quite like it's filling the screen.
All right, I can definitely. Okay.
Yeah.
All right, there we are. Maybe it's not exactly the. Okay, let me just go ahead, because you see something, and you can indeed also just listen for a minute here, because it is just this one slide. And the main topic is the question about economic advantages and for whom. So we are impressed by what we heard before, the relevance of the UK metals industry with like over 11,000 companies and underpinning as a foundation industry, roughly 200 billion of the UK GDP. So it is quite a relevant part as a foundation industry. And in order to understand in this system thinking spirit that we just heard, what happens if this component of a larger system becomes more circular, what happens with the other parts? We thought we really need to do some macroeconomic analysis. And that is also playing into the larger embeddedness of the UK economy in the globalized world, where indeed metals chain are so vital, because the larger share of metals is being imported in the UK, and there's a rather tiny share that is being exported. So you could, for instance, look at the share of metals that is globally imported, that is imported into the UK, and then compare it with the export of scrap steel. And the ratio is roughly 1 to 10. So really an enormous amount of metals being imported and a rather low share that is being exported, for instance, as scrap steel. And that was one of the questions that was also raised in the chat. And indeed, I can also alert here anyone who is interested to Chatham's House resource database. When Fan asked me to share this consortium here, I was really impressed and felt inspired by his vision of circular metals. The question therefore really is, that comes from me as an economist to our friends and colleagues from metallurgy and technology, what happens on the markets if high quality materials can be produced via reuse and repurposing, via liquid metals and other means? How would we then boost the markets for circular economy metals and how could we produce value, and what would happen in the larger areas that are underpinned, plus on the global side, if there is a reduction in demand for resources, if there is a larger dematerialization eventually, or indeed, if the extractive economies from today will not be able or will be less in demand with their extracted commodities in the future. So all these are larger economic repercussions. What we will do as part of this project here is that we will look more into the pricing of metals. And here's a question I would like to raise. It leads into the panel discussion that we have in a minute. Are the prices for metals higher or lower than 10 years ago? We'll answer it. So one of the activities that we will undertake is to investigate more into the development and the drivers for prices for metals in the UK and internationally. We will be hiring a PhD student who joins us from China to also undertake a bit more analysis that looks into this very pivotal market for the globalized metals economy and look into like how metals are being processed in China. And the probably interesting piece that we try to bring in here is a macroeconomic model. That is what you need when you need to look at the winners and losers, the size of the cake, and the expected gains for the UK economy under different scenarios. It's a model that we have developed, and we, that is, well, two more people from UCL who are with us here today, Matthew Winning and Alvaro Calzadilla. There's a model called UCL Engaged that is based on updated input-output tables. It has a global representation. It has global commodity trade in it. And it has also all the extensions that are needed into environmental accounts, in particular carbon, but also other environmental data in it. It is what the economists call a global, a computable general equilibrium model. And fortunately, it has been established over the last 5 years. We did a paper that I can share in a minute about steel and what would happen if the largest steel producer in the world, which is China, would shift into using more scrap steel over the next decades. And guess what? Even China would benefit, despite indeed a decline in the primary steel production, and the rest of the world as a majority would benefit from it because there will be more a supply of steel in the market. So that is but one example of the type of work that you could do with the sake of a macroeconomic model, all indeed open to conversations about some of the assumptions, some of the equations, and indeed the scenarios that we would like to develop together with the people here. And then thirdly, we will also have a stream of analysis on the role of society, the role of consumers, public awareness. I may wave my hand here to Mark Miodowink, who will have the pleasure of leading this part of the work on behalf of UCL. I'm stopping here. I think the main part will also then lead into all the broader conversations that we'll have, not just about a circular economy with Fiona, with the hub, with the 4 other centers, but also what we learn is indeed the main mission of the UK for the next years, the net zero carbon agenda, and the role that a hard-to-abate sector like the metal industry might and should be able to play. Thanks a lot.
Thank you, Raymond. That was Professor Raymond Bleichwitz from UCL on circular macroeconomic modeling. And we've come to the end of this part of the program, and we have scheduled a small break here before we go into 2 panel sessions, where we really get into some of these questions that have been coming up in the chat. But I know that we're running slightly late. So can I suggest that we cut that slightly shorter than it is scheduled and reconvene at 12:45, that's London time. So in 7 minutes, we'll start the interactive panel session. That will be with more academics from the centre, and we can get into the details of what we're going to be doing and the crucial questions we need to address. So reconvene at 12:45, everybody, for the panel sessions. Thank you. Thank you for all the speakers up till now. And I hope you agree it's been an exciting morning. See you in a moment. Hi, everybody. I'm back, and we are scheduled to restart in 1 minute, if that's good for everybody. And this will be a panel session. And it's the first of 2 panel sessions that we will be covering in the next 40 to 50 minutes, which will then lead on to a final question and answer session. And before that, we're going to have one more presentation by Martin Jarrett. So we've got 2 more panel sessions and then a presentation and a question and answer. And that will conclude the presentations for today. But we are now going to restart, and it is a panel session. And the question we are asking, and we want you to engage with, asking questions in the chat, but we might also cover some of the questions already answered, is the barriers to circular metals. Why is reality harder than the vision? And on the panel, I would like to welcome back Raymond Bleichwitz, who we heard from before. I would like to welcome back Professor Fan, who is leading the center, onto this panel. And I would like to introduce you to 2 more members of the panel, which you haven't previously heard of. One is Professor Jeffrey Scammons, who is a professor of metallurgy at Brunel University and the Chief Scientific Officer for Innobuild Technology Limited. And I would also like to introduce you to Professor Claire Davis, who is from the University of Warwick, and she is part of this centre too. And she is a Royal Academy of Engineering Tata Steel Professor of Low Energy Steel Processing. So we cover economics, we cover metallurgy, and in this panel, I want to start addressing or helping start the conversation about some of these really gnarly questions about how we actually get to circularity of metals. And I'm going to kick it off by asking, well, 10 years ago, as Professor Bleichwitz said in his presentation a minute ago, 10 years ago, prices were higher than today. And that doesn't really correspond with the supposed scarcity of materials. So what is the real problem here? What is the issue that we're trying to address? Perhaps I could start with you, Raymond.
Well, I guess it might have been seen as a surprise to some of the attendants here that the prices are actually lower, at least slightly lower than they were 10 years ago. And that is something that, well, people can figure out studying IMF's commodity prices. I looked at the base metals, steel, aluminium, etc. And it's interesting to see that prices actually went downwards for 4 or 5 years. They had a low level around 2050 and started increasing again. So when you might have seen the newspapers in the last days with concerns that are raised about rising prices, this is a more recent trend. And the trend over the last 10 years has been quite volatile, and the prices are now roughly where they used to be, but no increase. No internalization of negative externalities, at least not to the extent needed when we look at all the concerns over carbon footprints, climate change, planetary boundaries. And that signals to the circular economy investment community, why bother? The primary production route will get us there when we look at affordable, high-quality metals. And that is a wrong signal. So what instead we would need to see is a pricing mechanism that addresses the carbon challenges, that addresses and gives incentives for investments into areas we probably discuss in a minute. And this would also need to respond to the typical stable capital and operational expenditures that you have when you're running recycling reuse facilities against all the volatility that exists on the primary commodity markets. Reasons, you could ask, it's basically market fundamentals. There's not much voice of a circular economy or any environmental policy in that particular area. Regrettably, but that is one of the barriers that we need to overcome. We can discuss how, but that's the first point I wanted to make here.
Professor Scammons, do you have any comment on this, or is this a sector issue, perhaps?
Well, I look at the price of aluminium, and I have been monitoring it over many years. And yes, probably the price actually remains quite stable. It probably has been going down when you look at taking inflation into account. But and what is really interesting is that the average price of end-of-life scrap is about half the prime metal price on average, which shows that if we could actually do far more with the end-of-life scrap than we do now, we could actually either make our businesses more profitable or make metals easier to use in more applications. So to me, it just says because the price of a much better raw material, which is end-of-life scrap, is really the one to watch. But it's we're in a real mess at the moment in the UK because we don't really make much primary metal of either steel or aluminium, but we export a considerable amount of our end-of-life scrap, which is totally ludicrous. I mean, it's just wrong. I mean, nearly all the aluminium that comes from end-of-life cars and probably the steel as well goes out of the country, and it comes back in the form of high-value products that we buy again, and it just shouldn't be happening. We shouldn't be landfilling metals to the extent that we are, and we shouldn't. And it's just which is why all this is just so important. And there's some really simple low-hanging fruit that we can actually get from doing that so much better.
Thank you, Professor Davis. So low-hanging fruit. There's quite a few people in the chat. Mike Clinch and Panas Ephremides all asking about, what is this missing link? Why is scrap not valued? What is it that we're missing?
I think a large part of that answer has come from the starting point of cost and value. I think that actually, one of Raymond's comments there, it's interesting that I would consider it a success of research and innovation and technology that we actually keep the price so low, is because that's where we focus a lot of time and effort. So as we move now into understanding the importance of the circular economy and the fact we can't keep relying on making or taking primary material, yes, we should still continue to push that and make that cleaner, which is going to be a huge part. And some of the comments we've seen in the chat about the links to foundation industries is very important to achieve that. But I think we do need to look at the combination of new business models, but also thinking about the technology approach. So this idea currently we have very good assembly manufacturing. Perhaps what we also need is to put a lot of time and effort into disassembly, remanufacturing. So some of it is a thought process, and some of it is about the technology to make that efficient in the same way we've made primary metal production efficient.
Thank you. And Professor Fan, so what is your view on this conundrum? Is it a science problem, or is it an economics problem fundamentally?
Okay, thank you. And I don't think it's a scientific problem, but definitely the problem is a multifactorial issue here. And for example, I see we are not recycling aluminium and steel with either country, and which because we do it, we lose money. And that's, you can see that's a pricing issue, but that pricing problem is not UK alone. And it's worldwide because metal prices is set internationally. But the origin of the problem is how we price metal, okay? And metal, we know, for example, aluminum, 1 kilogram produce 12 kilograms CO2 and takes roughly about 12 to 14 kilowatts of electricity, okay? It's very energy intensive, CO2 intensive. but have a price very similar to potatoes. You can see the comparison with this. Is the problem is if we got a price right, if the material costs a lot more, and the recycling will be much more profitable. And then it comes to another factor, which is who is going to do it? It's a free market economy problem as well. Is profit driven or environmental protection driven? That's two conflicting views and factors fighting with each other. That's my point. Thank you.
Thank you. So we've got a few questions here, and I'm going to read them out and ask for my panelists if they want to talk about them. But we have one here about the links from this centre to the London's Metals Exchange and the stock market. What role do those links play in trying to unpick the problem of scrap? We've got one here who says that the scrap export and the absence of UK organisations to organisations to make metals cost effectively isn't happening. What is going to move on that front? And here from Anne saying, it's a good point from Claire about disassembly and remanufacturing. Huge opportunities are being missed here. Are these economic opportunities? And this business of extending the lifetime of products and reusing products, this mindset seems to be absent from industry at the moment. Any of those questions you'd like to have a go at? Raymond.
Well, yes, I mean, we start in parallel also responding to the chat, but the point I would really like to make to the larger audience here that today it is difficult for anyone who is purchasing a more greener type of metals to really have a certificate, to be aware of the premium content that this metal is composed of, because there is a limited labeling, distinction sort of policy. And that is what the London Stock Metal had started to change with their green aluminium initiative. They wanted to set up, or they have proposed to set up a platform for what they call green aluminium, which comes with a lower carbon footprint. And that is something that you would think is very much welcome, because it helps all investors, the finance communities, industrial customers, in a way also the larger public, to spot companies and their premium products that are more favorable. And I understand it has got stuck. It has received some resistance from industry. Some of them saying it is not green enough. Some say, well, it's just too green. So that is like an internal discussion that I would very much hope we can feed into. And I would very much also hope that we can give some evidence how London Metal Exchange and other such places could help to distinguish and therefore accelerate the transition to a more circular metals economy.
Thank you, Raymond. Jeff.
Yeah, I guess it's very clear we shouldn't be paying more for green. That's very clear. I mean, I think the whole idea that for green aluminium that the price should be higher is ludicrous. What it really is, and there's a very good point made by Mark Jolly, that the real price of primary metals must include all the issues, must include paying for all the issues that primary production actually causes in terms of all the knock-on effects, in terms of the CO2 and all the other environmental issues that primary production causes. I mean, that's not when you're buying that metal, you're not paying for the cleanup of those issues. So it's not a realistic price. I think that's the key thing.
Thank you. And Claire, about the disassembly, I mean, how does that, is there a premium on products that are not scrapped entirely, but are used functionally? How would that factor into this?
I think firstly, it's about getting the technology right so we can have confidence. And I think that's very much the case, that we need to have the confidence if we're going to disassembly and reuse, that these materials have not reached end of life, and therefore they have second life. And we see that now a lot with batteries, but the question is whether it can be reused in the equivalent or it effectively really gets downgraded. And so there does need to be this smart manufacturing. We've had comments about that before. We need smart disassembly and life assessment so we can go through that process. And then we need to put it into the bigger picture with when we can remanufacture, when we can reuse, when we do recycle to make sure that we get the quality going through the system. And coming on to the comment that's been made and raised in the chat about the recycling side of things, then we do need to be aware of the investment that's required to transition from some of the primary metal production into more of the recycled scrap use, and make sure that it stacks up. And that's why we need the business sector, the supply chains, as well as the technology, because we have the technology for using more scrap, but not necessarily in an economic way all the time, or a new business proposal way when you've already got established processing. So I think it's quite complex, and that's why bringing all these aspects together is so important.
Mm. And there's tons of questions. There's too many to answer. But I think I'd like to reassure people posting these that we will we will be opening up new events and welcoming you all in to talk about these individual points. But Professor Van, I'd like to just ask you about this business about, there's two major metals that the center is considering, right, and focusing on: aluminium alloys and steel alloys. Is there some sort of competition between the two of them? You can imagine actually that from an environmental perspective, they might actually have very different outcomes in terms of the way that pricing happens on them, and therefore that there might end up being competition between these two massive sectors. I mean, there already is, obviously, but how do you see that playing out?
Yeah, I think I have a quick answer. I would ask Jeff to answer with more details, and he got more expertise in this area. I think the competition, even including other metals, okay, like so-called critical metals, the current competition and the future developments, we see longer term full metal circulation, and currently it's more linear. And if we think this is this time scale, that's a different question actually. Currently, the competition in long run may not be competition at all. That's one issue. The other issue, the competition comes from here. Like what we said, we need to treat metals more, with more human touch. And aluminium and steel, they serve different functions for different purposes as well. And why don't we use metals for use their strengths a lot more, rather than going, competing for everything, in one go? Jeff, do you have any?
Yeah, I'd just like to add, I think the element of competition between the two wonderful big use metals, steel and aluminium, is all very positive. I think from the aluminium side, we can look at what the steel industry has done over the last 10, 15 years in bringing in much better material properties across the whole steel industry. I think that is fantastic. What's gone on there, and I think that should be a major challenge to the aluminium industry to do something similar, to understand how steel has improved its microstructure to get better properties. That's a perfect challenge for the aluminium industry to do the same thing, because microstructure determines properties, not composition. And that's basic physical metallurgy. It's just and it's something everyone should have tattooed on their forehead, really, because it's really not composition. It does to some extent, but not to the same extent that microstructure does. Get that right, and you can do almost anything with these wonderful materials. I think, and so the aluminium industry can learn from the steel industry in terms of alloy development, I think, at the moment. And I think the steel industry can learn from the aluminium industry in the way that aluminium recycling is handled, which is basically a remelting operation. Whereas in the steel industry, it's almost back to a refining operation, as Fan touched on. And I think there's learning both ways, and to have both of these wonderful metals in our centre is just perfect. Yeah,
that's a very good point, isn't it? And I'm just going to hand over to Raymond and then Claire before we end the session. And with Raymond, I'd like to say this: that point about Jeff about the different resmelting operations. This factors in energy, and suddenly, the energy costs might become a big issue here, right? Especially for UK industry for dealing with scrap and reprocessing.
Well, definitely yes. Partly the price and costs, but also the mode of how energy is being produced. You can imagine that in some countries they might have advantages, and some of them have hydropower, where electricity, for instance, is relatively cheap. But some also have subsidized coal-fired power station. So there's definitely also the element of an undesired competition in it, and it will be a policy challenge in the UK to make sure that the energy that goes into those processes is affordable and also is indeed in line with the net zero carbon ambitions. There was a discussion about hydrogen that can be applied to steel a minute ago, but that probably leads into another interesting cycle of how we can also use alternative energies and at what price and what the sort of system thinking around those things would be.
Thank you, Raymond. And Claire, while we're talking about energy, what role do you think hydrogen will play in the future?
It could play a significant role because it could allow us to have carbon-free steel manufacturing, for example, and there are quite a few programs that are going on internationally to investigate that. The one thing we'd need to look at is the production of hydrogen, and is the hydrogen carbon-free before you start using hydrogen for carbon-free metals production. So I think it is a very important part of the consideration, but not necessarily the only solution to some of the issues that we've got to deal with.
Thank you very much. We've run out of time for this panel. I know it's a tantalizing little microcosm of many of the questions, and you can see on the chat there's many more we haven't got to. I'm sorry about that to everyone, but we're going to move on to the next panel. Just like to thank Professor Scammons, Professor Bleichwitz, Professor Fan, Professor Davis for being part of the panel, and move on to the next panel session, which I'm also going to hand over the chairing of to Professor Jan Godsell.
Hi, Mark.
Hello.
Hi. So it's my great pleasure to introduce our second panel, which is looking at new business models for circular metals. Could we move to the next slide, please? So I have a great set of panelists. So first and foremost, we have Nancy Bochen, who is a professor of sustainable materials at Maastricht University. And she looks both at sustainable business models and business experiments for sustainability. And she's been involved in projects like Circular X, which is an ambitious 1.5 million euro 5-year research project funded by the European Research Council about experimentation with circular business models. We also have Fabrizio Session, who is one of my co-investigators on Work Package 3. And Fabrizio has come from Politecnica di Milano, and he is currently at Brunel and a senior lecturer in design for sustainability, and seems to have appeared into all things to do with the design for sustainable manufacturing and human-centered research design. We also have Matthew Winning, and I'm beginning to think here that what with Mark and his latest Radio 4 series, and now we have Matthew, who is a regular at the Edinburgh Festival Fringe. I'm beginning to think you can't work at UCL unless you are some kind of superstar broadcaster too. But Matthew, as well as being involved in UCL's Policy Commission on Community, as well as having a background in environmental economics, he's actually found ways to make economics understandable and works with UCL's Policy Commission on communicating climate change, climate science. And last but not least is my colleague from WMG, Zushu Lee. If it wasn't for Zushu, I wouldn't have been working in steel. So he's a visionary too, a bit like Fan, who perhaps saw that although his background, having come from the steel industry, was perhaps on the more scientific aspects of steel, he could actually see that there was a need to start to look at some of this from a more circular business model perspective too. So thank you all. So if we stop sharing the slides so that we can see our lovely panelists. My first question is to Nancy. You could see from the chat that there's a lot of concerns here around how these things are going to be affordable, and suggestions about what this might mean for new business models. What do you think are going to be some of the biggest challenges that we see from a business model perspective in terms of making this transition to circular metal?
Yeah, so thank you for inviting me to the panel. Yeah, I actually wanted to make a few points related to this. So first of all, I think one of the challenges is the focus on environmental impact. So what we see is when companies start thinking about some of those new business models, they start thinking about new services, but without really thinking about the environmental impact anymore. So sometimes they design something interesting, but then they don't really calculate the actual impact of some of the models that they introduce. So you already talked about this slowing, closing and narrowing the loop. And I think a lot of the focus is on closing and narrowing the loop, so on recycling and efficiencies. So one of the most challenging business models sometimes for companies is to think about slowing the loop or reusing products and making money out of that. And I think the main challenge is also something that I basically address also in the Circular X program, and that is starting to experiment and challenging the dominant linear business model. I don't know whether I have 1 minute more, but basically for slowing the loop, there were questions earlier on how to make this economically viable. I think that is also one of the challenges. And I think there are a few business models that make it more viable. So it would either be the premium model, so delivering something that is much better than alternatives. So then you could charge a little bit more, charging this type of service, but then also keeping in mind the environmental impacts. But also, selling the same product twice or multiple times, like second-hand, third-hand, and fourth-hand markets. And finally, I think this is one thing that I would like to introduce also in our markets in the UK and Europe, is also the low-cost, more frugal model. So think about maybe smaller cars, using less. So why do we need so much stuff, basically? So I think also the low-cost, frugal model is something that can save costs and can be something quite exciting also for the customer, potentially.
Thank you very much, Nancy. No, I fully concur with that. And if you think of the likes of Sir David Attenborough and some of his recent podcasts, you know, he's essentially encouraging us, particularly in the developed world, to perhaps be less consumeristic and to consume less. And that's obviously a challenge for businesses to actually think about how are they going to still have a viable business in a world where actually we consume less. But, you know, that link between responsible consumption and production, United Nations Sustainability Development Goal 12, I think is critical to all of this. Which brings me nicely on, Zushu. We became connected over your passion for scrap steel. Yes, there is such a thing. And actually your interest in thinking about how steel scrap recycling technologies, which aren't something you necessarily think about every day as being a critical enabler to a more circular economy. Explain a bit about your interest in this topic and why they're so fundamental to us making this transition.
So thanks, Jen. So the scrap recycling things is actually, so it's probably most important. The scrap recycling is not for the circular economy, but it's an important part of the circular economy. So everything at the end of the life, after we take the reuse and the reuse, remanufacturing, they have to go to recycling and they come back to the life. So when I'm interested in the circular economy, metal recycling, it's basically, I'm thinking that the current metal recycling, there are all sorts of issues we need to fundamentally change. And I think Professor Fan had drawn a very nice analogy between the metals and the human and the human. So when we talk about the recycling, there's one big issue is from people, humans concept, and also the business model and the recycling technologies is, if we look at the human, after those, we think about the donation of organs. But in the metal, we just start to think about the remanufacturing, reuse. And so far, most of the process is just recycling. And then the recycling now, the business model or the technologies is mainly for how to best sell the scrap, not really for best to how to recycle the scraps. That is the second point. And the third point is we worked quite a lot of projects about the business model. Current recycling is mainly less concerned about the closed loop or circular, that concept. So a good example is that I have seen in industries is a typical high-grade steel, high-value steel can sell at a few thousand tons and sell to customer, and the customer manufacture, and 2/3 or half of them will become the turnings. And when it becomes turnings, and then they will mix with other turnings sold to the recycling companies at 20p per ton. And they didn't consider how to sell the scrap back to the recycler, to the steel maker. That will be much higher value. So that means the whole system didn't consider the circular concept. So that's all my interest in how to improve the scrap recycling and the related, and that's probably last few years my main research are focused on.
Yeah, thank you very much, Luciu. Very valid points about, you know, potentially closing the loop, and that in itself would result in a different business model. So Fabrizio, you come from the School of Design. What do you think are the challenges there for design, and what are the implications, barriers and challenges that this will present?
Well, I would say that designing circular business models requires a different design mindset and requires a new design knowledge and skill set. And this is particularly true for traditional designers who tend to focus on designing individual products. So in these cases, we might see integrating elements of sustainability and circular economy into product design, but this is a quite narrow approach that can produce, I would say, limited sustainability benefits. So designing business models requires a much broader design perspective, a much broader design focus. And first of all, this is related to the design of a value proposition. You have to learn to move beyond the sale of products to consider a wider range of models. So talking about selling the performance, selling access or sharing of products. And this entails that designers have to learn to shift from designing individual products to designing combinations of products and services. And this, of course, entails that designers also need to understand how the value proposition is linked to all the other parts of a business model. So value creation, value capture, and value delivery. And another important skill set that is required by designers is also to consider the value chain. Sometimes in circular business models, we have very articulated and complex value chains, and identifying these stakeholders, engaging them in co-designing process, and identify who is doing what within these complex systems is an important skill for designers. And then it's also important to link this on the technical aspects of product design, because with the designing of business models, you can create these environmental and economic opportunities, but then you need to properly design products in order to exploit these opportunities. So understanding the link between business models and products and materials, it's crucial for design. So I would say three main skills to broaden up the design scope, including business models, supply chain, being able to co-design with not only with users, but also with all the different socioeconomic stakeholders that are required in complex circular business models, and also get an in-depth understanding of the sustainability implications of different business models and different product designs.
Thanks, Fabrizio. And I think that links nicely, touches on a question. I think we've sort of had two questions, one from Mike Lynch and one from David Peck. So Mike was asking about whether there was a metals industry equivalent of Rolls-Royce. I think we are beginning to see these business models of leasing, perhaps, of the material. So if you look at, I'll drop it into chat later, but the likes of River Simple, which I appreciate is still a business that's more embryonic in its form, but essentially that's a business that's designed in a very different way, right the way from the structure of the business to the way in which it actually leases various different components through its life cycles. That's a good example. And I think building on David Peck's question then about, you know, is this just a environmental thing, or do we also need to think about the societal thing? I think actually when we start to think about that UN approach, you know, responsible consumption and production, as you talked about, Fabrizio, when we start to think about what the value proposition is, I think increasingly the way in which we bring together consumption and production brings together the societal and the environmental. So last but not least, Matt, and I am, you don't have to make us laugh, though I really am looking forward to talking to an economist who can actually explain something in a way that I understand. So no pressure there. But how could policy in the UK just makes everything challenging. So how could we actually use policy in a way to help global companies perhaps, I suppose, design their global value chains in a way that the UK can play a part proactively supporting this?
Yeah, no, it's a really good point. And I think another couple of questions have just come through recently that in the chat as well that allude to these exact issues. You know, we live in such an interconnected world, you know, and that's what we're trying to capture a little bit in Work Package 4. You know, the imports and exports are pretty massive in terms of metals for the UK. And so, you know, there's a sort of a first best world idea of what would policy look like? How would we try to get business models up and running? And I think that's what a lot of us as academics deal with, you know, starting from an ideal world where, you know, we're starting from scratch. It's kind of easy enough to design policy that would work with a lot of these business models, but then in reality, you know, there's a lot of really complicated things that make it difficult in the UK, especially which has been talked about once or twice. Electricity prices in the UK for, you know, for recycled metals is a massive part of it. Driving down electricity costs for industry could play a really massive role, especially given, you know, I think it was alluded to earlier, but, you know, countries like Sweden and stuff that have lots of hydropower and also have quite a massive steel industry are able to sort of take ahead the innovations and start undertaking the innovations there because they have the capital to do so. Whereas in the UK, that can, yeah, this is quite a different picture in my opinion. But we have an abundance of renewable energy, and we're increasing through, you know, the government's 10-point plan and other things massively in low carbon generation. And if that is able to drive the price down, if we really, you know, think about adding additional wind, etc., that's able to bring the cost down, as well as potentially subsidies for that area, then I think we could drive down costs in a way that will really benefit us, because we do have the low carbon electricity, we do have a lot of the skill set and the kind of historical expertise in this area. So I think it's important in the project to look at both those things, you know, to look at what would an ideal kind of situation be, and also what is the reality that we're operating in, and what is the international context of that. You know, a lot of companies are global that we're talking about here and are making decisions based on policy, you know, what policies are across a number of countries that they operate in. And I think, you know, the UK really improving and changing its regulatory framework to incentivize people to, or companies to come here and innovate is, you know, it's something that Brexit potentially encourages, but at the same time, a lot of the same companies operate EU-wide and therefore need consistency across the EU. So it both is a potential benefit and also a potential difficulty, I think. So all of that needs to be sort of traded quite lightly when we think about businesses. You know, a lot of the businesses we're talking about here are not UK companies as such. Well, it's a UK industry, you know, there's a much more global perspective that has to be constantly kept in mind when we're thinking about this, and especially when we're thinking about, as Sushu talked about, you know, the scrap being traded elsewhere and coming back to us. And we really are in a situation where we're exporting a lot of low value metals and importing a lot of high value metals, and it's not a good starting position for me.
Thanks, Matt. So thank you to Nancy, Zushu, Fabrizio and Matt. I think what we're going to see through, I think, both work package 3 around circular business and also through work package 4 is some of these questions addressed, because as Mark Jolly points out, at the moment, the UK is the largest net importer of carbon emissions in the world. And I quite often get asked from a supply chain design perspective about, you know, are we going to see as a result of Brexit more reshoring? I think one of the words that's being used at the moment is this idea of green shoring, but actually if we start to actually truly take into account the cost of carbon and think about the sort of carbon economics in a different way. So we're not just making, cost is a massive driver of all our supply chains at the moment. So if we start making those decisions based on cost of carbon rather than just economic cost, we might start to see some differences in the terms of the way that we look at our, not just our supply chains, but the business models that then support it. So thanks to everybody, and I'll hand back to Mark.
Thanks, Jan. Thanks, panel members. That was great. So we're now going to move on to the final panel session, which is making metals circular, the aluminium and steel industries. And we have a great industry panel for you, which is Martin Jarrett, Mark White, and Gareth Stace. And I'm going to introduce them and a little bit of background information to start off the panel, and then we'll get into questions. And I think I might bring back some questions from that. I mean, there's so many questions on the chat, which is great, but I think some of them, I think our panel could answer. So I am going to share my screen. There's Martin. Hi, Martin. And I am going to just bring up those slides. Okay, so there we go. Here's the panel. Hello, everybody. Right, so just to introduce everyone. So Martin Jarrett is Global Technical Director of the Automotive Structures and Industry Business of Constellium. Gareth Stace is Director General of the UK Steel. And Mark White is, he's held many technical roles at Jaguar Land Rover, and now has many consultancy roles. So welcome, everybody. Thanks for joining us. It's great to have you here. And I'm going to just go on to the next slide because, well, you all gave me these slides, but I feel like, just setting the scene to our audience out there. So we have this ambition of a circular economy and changing how metals in particular move through a circular economy. And the question of scrap has come up several times, and how we value scrap, but also how it moves through the process and ends up where it needs to be, and the energy required to do all that. All are, it sounds an easy thing to say, but turn out to be a very complex and problematic and largely unrealized ambition. So taking automotive as an example, and looking at, what used to be almost predominantly steel objects in our lives, and more are moving to mixed in terms of the two major metals of steel and aluminium. But how much of that are those metals get recycled, and in which way they get recycled and reused? This diagram is quite, it paints a picture of extremely different use practices across many countries in the EU, with the United Kingdom recycling almost all of it by exporting out of the country, it looks like, from this data. And there's various, other countries do various different things. So perhaps we can come back and discuss this issue, but I'm just going to go to one more slide, which is that what happens to those destinations for the aluminium scrap. And it's to countries like China and India, Pakistan, and others. And this is EU exported scrap. This is now no longer just the UK. So almost all of it is exported to Asia, as if the EU doesn't need it, or have any markets for it, or have any capability of dealing with it. And that seems to me to be, well, obviously driven by markets, but maybe it is in a sense one of the issues to resolve, one of the issues to first talk about in this panel. Why is this the case? And is this driven mostly by cost, or is this driven by environmental conditions in different countries and different regulations? What is the role of, let's say, legislation in driving this, and what is the role of essentially just pure cost? Can I ask Mark White, what's your feeling about? I'll stop sharing this first and turn to you, Mark White.
Yeah.
Is it regulation that's driving this, or is this purely cost?
So just a quick update. I'm actually retired from JLR 5 years ago. So just to be clear, I know there's some JLR people on the line. So I think there's a couple of things that are driving it. The first thing is that we don't have an infrastructure in place in the UK to effectively reuse and at what I would call upcycling or not downcycling automotive scrap. And I think we need to address that. I think there's three phases what automotive has to do going forward in the circular economy. The first stage is to actually stop talking about CO2 equivalent in terms of is it 16, 8 or 4. We should actually be aiming for zero carbon for our initial metal manufacture. Then we should be using the metal that we're making vehicles out of in a more productive way, things like closed loop recycling and looking at end of life scrap recycling rather than just using primary all the time. And I think the second stage in the program is actually to develop new alloys that are tolerant of these end-of-life scrap and in-process scrap. So things like the Real Car project that JLR pioneered, where we're actually using secondary metal as the main source for manufacturing components, is a good step forward, but it's certainly only a step forward. And then the third thing, from my point of view, is as well as putting that infrastructure in place to recycle that scrap, we need to be looking at reusing and extending the life of our products. So for example, today we effectively throw a vehicle away when some of the components fail. A lot of the components on that vehicle could last a lot longer, and through this metal health service and through monitoring through digital twins and technology like that, we can actually see which components we need to replace and which components can last twice as long as the rest of the components on the car. And I think with electric vehicles, that makes that more possible, because we can upgrade vehicles through software over the air, for example. The battery pack and the electric motors tend to be more reliable and have a longer life than a mechanical system. And so we might get into a situation where we start to design for assembly and disassembly, and we only replace the parts that are wearing out and refresh the vehicles both from a connectivity point of view and an appearance point of view, to extend the life of those vehicles.
Thank you, Mark. Martin, is this the direction of travel for the automotive industry? Design for reuse, design for repair, and are the economic incentives there to do it?
Well, I mean, it's obviously an interesting, it's a broad question. And I think certainly the incentives, I would say, are not there to do it at the moment. And that's something that I think needs to be built into, to any future program, certainly on sustainability. What I think is a really key point, though, and I'm just going to move back for a second onto what Mark's raising about scrap, because I feel really quite passionate about this. Is that we don't treat scrap as a strategic resource. We the industry I'm talking about now, we treat scrap as something to sell, and that has to change. And I think that's one of the fundamental things that this circular metals program needs to address. And that's certainly one thing that we will be championing as part of this program. It's really important that that's addressed. I also then see closer partnerships with recycling companies. I think they have a massive role to play. And I think the UK is well placed to develop that technology. And I think this is key to addressing a number of areas. And one thing, just from an industrial point of view, when you're transporting metal around, it's actually difficult to transport just, if you like, scrap, because you've got a lot of fresh air in your load. If you can actually convert scrap into highly dense packed material that you can then send from the UK, for example, to other areas of Europe, then it becomes an economical way to operate. And I think some of these areas, and part of the sort of, the position the UK could find itself in this sort of revolution almost, if you like, could be really interesting. So I think that's also part of the story. And I think the other thing is that the idea to create impurity tolerant alloys is really important. But I think it's also critically important to develop those with the customer, because at the moment, what we would tend to be is you would get a request to supply to a low CO2 embodied material. But the consequence of doing that may mean that you have to work with that customer, perhaps so that they accept that it will be made of alloys that are contain more impurities, behave just as good, just as well. But we need that connection with the customer as well. And I think that also gets around to, the legislation about using our products for longer and reusing them. I think that whole customer connection is part of the story.
Thank you, Martin. And Gareth Stace, can I bring you in here? And so what's your view on scrap? I mean, some people, in the chat I see are kind of worried that we're sort of talking about the lowest, in a sense, the end point too soon. That reuse and longevity for steel products, let's say, would be an advantage. But how do we make that economically viable for the companies involved?
It's an interesting point, Mark, because I'm actually thinking of just the basic parts, because I think that the basics haven't really been tackled. We generate 11 million tons of scrap in the UK. We export 80% of that, and we leave us with a tiny bit of it. We could be using more scrap, even with the infrastructure in terms of the blast furnaces and the electric arc furnaces that we have already. And I'm sure this has been talked about so many times today, but in my mind, I'm thinking I want the UK steel sector to be the first net zero carbon steel sector, in terms of a country producing net zero carbon steel. And scrap plays a huge part of that, not just in the direct emissions of moving more to electric arc furnace routes, but in terms of the transport, which we talked about, scrap going across, coming back as a material. So, but what are the basic problems? And the basic problems are, I could say that if I was polite, better business alignment between scrap collectors, the processors, and steel producers. That was being polite. Really, they just don't get on. They don't trust each other. And that's the problem I think we have in terms of then sorting scrap as well. Talked about lots today, but also, which Martin touched upon then, in terms of there's only certain products that we in the steel industry can produce from scrap that our customers will allow us to do that. And so I think that that's a really important point, especially in long steel products. But the problem that we have then, so where we're sitting is electricity prices. You know, we're not going to see more investment in electric arc furnace or electrification of the steel sector in the UK, whilst we are paying something like, 70%, 60% more for our electricity than, say, France and Germany. And then also, the infrastructure of scrap in the UK is bulk export. And so, the unsorted rubbish scrap that has no value, it goes to large deep sea ports and is gone. And is gone from us. I mean, it's actually the same countries, but we export to Turkey quite a lot more, which the aluminium guys don't. So it's fixing those immediate problems of let's get on with that supply chain better. Let's sort better and understand where we can get that infrastructure from. But let's have a competitive business environment, which starts with electricity prices first.
Thank you, Gareth. So electricity is one of the components of energy pricing. Mark, what else would you what are your top 3 things that you wish could change?
Well, there is no incentivization for any of the OEMs, the car makers or the transport makers today to use what we would call secondary metal. I hate the word scrap, by the way. So secondary metal that's been used once before. There's no incentive to do that. And I think we've got to put both standards and some sort of, I'm not saying legislation, but certainly incentivize the use of secondary metal in future products. So I think that's a starter for 10. Then secondly, just reducing the total carbon footprint of the vehicles that we make through the electrification, through the reuse of components. If you looked at that original model of what people do with cars at the end of it by country, you'll find that a lot of the countries are prepared to basically strip the cars down and reuse a lot of the components because labor rates or there's incentives in place to do so. We have none of that. At the end of our vehicle life, we basically crush our vehicles and then shred them. So again, we need incentivization to stop doing that and actually start using metals properly. And then finally, I think it is implicit in the car manufacturers to start to design for reuse. I think that's a key thing that we don't do today. We know that there are components on the car that could be on there for 500,000 miles and more, but they end up in the same scrap pile as the components that fail at 200,000 kilometers or whatever the life of the component is.
Thank you. I mean that's a big, I'm a big fan of that. And Martin, I mean, this business about how to design for reuse and the reuse of components. When we see the massive growth of the electrical vehicle, this is a massive opportunity, isn't it, to change the design paradigm, right, for this new sector. Do you see hopeful signs?
Yeah, no, absolutely. I mean, I think what's really interesting at the moment, it's certainly working in part of the supply chain for EVs is if you look at the battery pack itself, and the battery pack seems to change from almost a full structural item to non-structural item. So it's got a whole swing of attributes to the vehicle. But you could imagine going forward that you could drop that battery pack almost as a sort of changeable item. And as a consequence of doing that, the battery pack could last many, many years longer than the vehicle, simply because that you're changing it and it's a changeable thing. So yeah, I actually see the electric vehicle as a really interesting way to change how cars are designed. And I think that's just one example.
Yeah. Thanks for that. And we're running out of time. I just want to give a tiny amount of space. Well, not a tiny. The last word to Gareth. There's Lucy Chamberlain in the chat is saying, why do recyclers and manufacturers not get on with each other around scrap? What's going on? This is a cultural thing.
Well, I think they have different understanding of what is a ton and what isn't a ton. But I think it's. Yeah, it's just that they're from different sectors, and we, when we produce steel in the steel sector, it's to an exact, standard, and our customers expect that. And when we buy scrap, we hope that it's to an exact standard. And often when we get it, even a bale of high quality beverage cans, we'll look inside that bale and there's impurities within there that shouldn't be. And so it's really, I think, we've just got to start talking to our supplier, and we're their customer, and getting better value either way. Because it is, as I said, Mark, it's all too easy for them to stick it on a very big ship and send it across halfway across the world.
Yeah. Well, that's what happens currently, and we hope to change that as a result of this centre being formed and this coalition of companies like yourselves and organisations like yourselves, commercial companies, economists and macroeconomists and academics and all sorts of companies. But thank you very much, you all coming to this panel, being part of the centre. We look forward to working with you in the future. Thank you. That is a whistle-stop tour through the kind of inception of this centre, both because of how the government have set out this call and set out legislation for net zero, and also the climate disaster imperative for us all to change the nature of capitalist consumerism. Through to the getting together of the centre by Professor Fan and bringing together different academics from different universities, including myself and the others that you've heard of today, and through this coalition of companies who are putting real cash into this, real commitment, you heard from them, and policymakers, and for those who, and many other organisations who are involved in the circular economy of metals and circular economy in general. So we're part of a much bigger, as Fiona laid out, a much bigger shift towards the circular economy. So this is a particularly hopeful launch of I think, an incredibly important new research centre. And I hope you've all enjoyed and feel that you've got your head around what we are doing, what we represent, and most importantly, that we're open for business. We launched this now as soon as we could because we really feel this is urgent. We really want to reach out, and we've done so, I hope, through the very good attendance across the world, because this is a global supply chain, as you heard, and the issues, they span both legislative issues that are different in different countries, CO2 targets, but also environmental conditions in different countries, so societal issues. And there's been so many questions in the chat that we haven't managed to get to them all, but we have recorded this session, and we will be noting down all the questions and coming back to them in future events. So I'm sort of winding up. You can hear me saying this, and thank you for your patience. We're slightly over, not too much, I hope. We've got down question and answer session, but I think that probably we've done quite a lot of that. If there are any urgent questions, please do put them in the chat, things we haven't clarified. I think that's the most important thing. You know who's involved. You've heard from all of us. You know that it's a coalition. You know that we're open for business and we want you to contact us. The website is on the chat, circularmetal.co.uk. Someone's asking for copies of the slides. I don't know if we have copies of the slides, but I do know that the video of this will be available with the slides embedded in it. Anything else to say? Any other questions anyone's got? Otherwise, I will close this meeting and say one final thing, which is a big thank you to the Brunel team for all your hard work and for the seamless, technically seamless production of this event. Kieran O'Shea has been the mastermind of it. Thank you so much. You've done a brilliant job. And I think that's all I will say now, except to say goodbye and hope to see you all again in future meetings. Thank you, everyone, for taking part, and we can work together in the future for a circular metals future. Hooray!
Bye. Hooray.
Bye.